Hi, welcome back. Last time we looked at the principle of minimum potential energy, in which case we defined the potential energy of any kinematically admissible displacement is this. And Castigliano's theorem says, and it has three parts. Before we go to Castigliano's theorem, the first part is the strain energy, the second part is the potential energy of the body force, the third part is the potential energy of the surface traction. If I count all of them, Castigliano's theorem says among all kinematically admissible displacements, the actual displacements makes the potential energy stationary. This is a very powerful result because it extends very beautifully for finite elasticity, and the set of kinematically admissible displacements have very few constraints. All you have to do is find a nice enough function that meets the boundary condition, displacement boundary conditions. Once you have done that, you can just use that and find minimum. Okay, I mean it sounds easy, but it's not as simple, but nevertheless that's the idea. Today we are going to look at the next one, which is called a Castigliano's, which is called a complementary energy. So given a statically admissible stress field, which I am going to abbreviate as SAS, statically admissible stress, its complementary energy for a Hookean material is given as complementary energy equals integral over the region of 1/2 Sij KL sigma ij sigma KL. Notice it's S not C, so this is dV minus integral T times U on dou omega 2. This is on displacement specified, displacement boundary condition. Notice this has to be a SAS. It's a statically admissible stress field which satisfies this condition. So now we talk about Castigliano's second theorem. Which says among all SAS, the actual stress extremizes the complementary energy. Notice no body force term, because the SAS takes care of the body force. You know, statically admissible means it has to take care of the body force. Now this one has limited applicability, mostly in strength of materials. Right? That's why we do Castigliano's second theorem, right? The Castigliano's first theorem is much wider applicability than Castigliano's second theorem. It's very useful for almost rigid bodies. We will have occasion to use it. So this is actually not unreasonable at all. We will use it for some purposes because it allows us to do some approximate solutions in a very nice way. Okay, so you got principle of minimum potential energy and principle of minimum complementary energy. By the way, it's not minimum, it's actually extremum, but if theCijkl is positive, if this SIJKL, this matrix is a positive definite matrix, that means all its eigenvalues are positive, then you can show that the extremum will be a minimum in both cases. Okay, and that's what we are going to look at. So we have seen the two energy principles. They are very, very useful. We will see some examples in class about how to use it, but that's the idea. Okay.